So it's my pleasure to invite Mr. Dipak Borah from Numaligarh Refinery.
Good afternoon, everyone. So, first of all, I appreciate and obliged to ARC Advisory for inviting me and showcase what we have done so far in refinery and the business as such. And I have tried to combine everything, whatever we have done in the digital front, including the operations and the supply chain and other areas of IT and workflows and other things, so that my presentation will be a bit long, but I'll try to cover up everything within stipulated time. So, sorry. So, NRL is earlier it was a BPCL subsidiary. Now we are part of Oil India. Now we are expanding to 9 million ton from the current capacity, and the project is in the advanced stage of completion. And we are also in a constructing a petchem project and cross-country pipeline from Paradip to Numaligarh. So 16,000 kilometers, and we have been recently declared as a Navaratna out of the I think 27th Navaratna company in India. So project is in a very advanced stage, almost 90% completed. So this is the whole umbrella of initiatives which we have covered. Being a refinery, it is a highly asset-intensive industry. Some of my earlier colleagues also said it. We are mainly asset-centric because we have to sweat our assets, then we have leveraged it, and people should be motivated enough, and we have a lot of initiatives are there on the people-centric initiative, and business process improvements and basically running the business. Process improvement covers both the operation technology side and the information technology and the other business areas. So around 30 plus initiatives are there, which is up and running. None of them are pilot, all are production gate deployment. And I'll be trying to cover at least 8 or 9 of them. So these are around 8 domains. Safety and IoT, as I said, safety is very paramount in oil and gas industry. Like my earlier speaker, ultra critical video analytics, that sort of analysis we have, e-permit solution, all these things have. Field mobility, we have a entire refinery-wide pervasive wireless infrastructure, which is say Zone 2 certified, and all our logbook, plant maintenance activities, RVI, RCM, everything is done. And drones and other things are being used for shutdown and other activities. Logistic, we have multiple solutions where we have leveraged extensively AI in terminal operations and logistics. So, and then there are many SAP, IBM, all these things, like the CRM and all. So AI, ML, IoT, these are the 5 broad domains. These are the domains which these solutions we have incorporated, and it's up and running. To start with, we have among the asset-centric applications, we have deployed an analytics platform. Instead of building a data lake sort of environment, we have connected this platform to the multiple data sources, around 13 different data sources, including process historians, ERP, LIMS, condition monitoring, then some around 12 or 13 ODBC data sources. So this is a basically unified data infrastructure which will help us to become three things. One is the key performance indicator for the operational areas, then predictive maintenance related issue. We have 220 assets, critical assets we have connected to this. We are getting those vibration readings, and also we are trying to build a hybrid model out of it. We have been successful in doing so, connecting to the IP210 process historian and collating the data with the condition monitoring and the SAP records. We build a hybrid model. So hybrid model means rule based as well as certain component of machine learning, like anomaly detection, then our remaining useful life detection, etc. Then another area is energy and emission monitoring. Echo 6 sensors have been deployed around 250 critical loops and pressure safety valves and the steam traps, which is giving us any leakage from the PRVs and the steam traps, because these areas are not very regularly attended, unlike your. So this, in a nutshell, this is the whole platform. Process analytics, enterprise dashboards, MIS reports, and the CXO level dashboards. So this we have deployed a solution from SAS. So this is a briefly will tell you that these are the assets, some of the assets, these are coming from one unit. So asset health score is predicted. Then based on that, certain analysis is also getting carried out, like vibration FFT for detecting some fault as per the vibration signals. The first fast forward transformation is that from the time domain data to convert it to frequency domain. Those are native algorithm in the platform, that is we are doing. And similarly, these MIS dashboards, and those are the dashboards for energy and emissions. This is the approach how we build it for the predictive maintenance part. Through OPC UA, we got process history data, vibration data also OPC UA, but with a different layer and hierarchy. Then maintenance history and SAP data, those things are getting collected. Then we apply certain statistical parameter, machine learning statistical, pure statistical things like spectrocartosis and all. From there, we try to derive what are the possible causes of failure. Then in the process, we develop around 15 plus root failure modes and the underlying causes. So the misalignment or say BPFO or inner bearing race failure, all these things. So this is running. These are some of the dashboards, and these are moving average dashboards of spectrum analysis, how we are making. So these in machine learning, where we are using, to be specific, is anomaly detection, support vector and PCA and issues. Clustering basically some of the outlier points, some are normal behavior. Then RUL, which is exponential degradation modeling using. Then SLH scoring, it's a combination of the process score, vibration score, and other parameters. So it is giving me a process score. Out of 100, what is the score? If it is below 70, 80, it is a good. Above 80 is good. So that score, which is monitored by my condition monitoring cell and some of the other. So I'll briefly highlight the impact. Earlier we had many unplanned downtimes, because we have now consecutively for last 3 years we have exceeded the plant capacity, that boilerplate capacity, and because of the running of the fan at the highest throughput, and plant availability has gone up because of the cultural thing and these were technology interventions. So seal failure, these are some of the impact. So rotary acid failure, then seal leakage, this is given by my maintenance team. So they have prevented early those leakages. So this is the impact what it shows. So I'll not go into much detail, because data silos, one of the lessons we learned is that data silos, all OT data integration with IT systems is extremely problematic nowadays also. IT, then there are collaboration required, and all systems are siloed systems. So there is no democratization of data is a problem as on that also. So that we feel. And I have some other many other things which I'll cover next. So this is the historian. This is how one of the use case, how we detected at least 10 days in advance. This is the dashboard. These are some of the maintenance dashboard. Then this is the how dashboard look like. This is the FFT transformation spectrum. So this is in a nutshell. Then the PSB and PSB, as it is known that whether it is cold plug, whether it is blow through, those alerts are coming from the sensors to a historian. And from there it is coming to the platform. These are some of the dashboards. Then cooling tower performance. The cooling tower is one of the neglected area, but it's very essential for the running of the plant. Any temperature delta, it leads to the performance of the plant. So that approach, range, the efficiency, all these are calculated online, because we are getting data from the ORP data, pH data, vibration data. All these things are getting from the cooling tower console, cooling tower through the OPC, through the historian, and from there we try to map it to the cooling tower performance, this range, approach, efficiency, then drift losses, etc. So this is also used by the utilities team. These are some of the dashboards. The safety dashboards are there, safety parameter. So yes, one thing I mentioned, in the same platform we are leveraging it for connecting to the 12 systems and deployed dashboards for multiple systems, maintenance, operation, safety, then marketing, sales, finance, all this. So this is a unified data infrastructure, as I said. This is one of the key initiatives which we have implemented. And second is my friend has already covered. It's a video analytics construction safety where around 14,000 plus workers are working in every day. So this is a solution we have deployed. I think from the same party. I think so. This is specifically tailored for construction site. Then 8 IOCP categories you will see. I'm not going to safety assistant, web-based streaming, progress reporting. So these are the dashboards and other things. So PPE violation, hazard, work at height, housekeeping. These are very important in a construction site. So these are the areas covered, lifting, hoisting. So impact is this. Now I think it is 75,000 plus unsafe behavior detected. And the alert immediately goes to the section in charge and the unit in charge, whoever is constructed the unit, and also the EPCM context. They take action. Not a single incident took place in last 48 months, and any even major mishaps. I would so not say lost time, but major incident also not took place. And though it is costly, it is a cloud-based solution in a VPC environment running, but it is worth the effort because we could no LTA and other things. So it's an impactful solution. So it is a human AI collaboration, and people have been deployed and running successfully. Another, it is in-house developed solution. Similar to that, we have a terminal. We face a lot of efficiency in the tanker congestion and the thing, where we thought of a different approach and deployed rearrangement the whole thing. Tank trucks are diverted to a particular location. From there, as per NPRS detects that the truck has reported. Then as per the OMC indents, it reports. Then there are big dashboards like this that come to know. Then from there, the entire process is workflow is automated, and it goes to the loading. Then PPE violation, all these things. So I will not go into the detailed workflow, but this has helped us significantly to decongest the terminal operation. Earlier we spent a lot of time, and now it runs in 250. We load 500 plus tank type in a terminal which was designed in 1999. So it is possible because of lot of efficiency improvement measures and such technology intervention took place. So these are PPE violation, then again facial recognition, driver identity, then CISF tank exit, all these things are taken care of. Now it has resulted in 40% reduction in truck turnaround time and wait time, and around 15 crore saving yearly. Another AI model is again refinery turnaround. We are using extensively drone and other things. Drone inspection, basically for stack and other areas, and occupancy monitoring, whether people are loitering, whether these things are used. And this upcoming shutdown also we are planning to use this from the last turnaround, and they report these anomalies or the things which is otherwise inaccessible to monitor. So these images. Another small initiative which is purely in-house. We have developed a solution. It is using VLM. So we face a lot of issues. For the upcoming refinery, we have to create around 7,000 material codifications, material equipment, plus along with around 20,000 plus additional material codification. And data has to be extracted from the BOMs from the engineering drawings. So how to do it? It's manually, it's a very challenging task. So we introduced the VLM. Then what it did, it has significantly reduced our time. Then the SAP upload ready material codification output is generated, and from there duplicate check is also conducted. Then we could be able to do it in a very short time. So this is how the dashboard, and we upload a file and provide the material codification input from the engineering doing it, extracts the both long text and the short text as per the taxonomy defined. Then it is imported and we give it to the SAP team for codification, and they upload it and upload the BOM to the respective equipment. So it is a very extremely cumbersome process. We could able to do it in a very short time. This is another we recently introduced. See, in SAP we face a lot of issues, lot of audit automation because of material duplicacy. We develop a solution in-house using a fuzzy logic, which is a classical AI algorithm, I would say. So to match the both long text and the short text, and to find out how many 100% long text and short text max material codes are there. And from there we could detect around 1200 plus material and worth of 6 crores worth of extra inventory. So that is a in-house deployment, and we could able to save and liquidate the audit observation. Now we put SEC in the material master codification itself, both the SEC, this long text and short text. It is a fuzzy search algorithm, both and also Jaccard. There's an algorithm called Jaccard, union of intersections. So that is used. Then in safety and IoT integration is there. In for permit system, what we have done, gas reading. We have a very exhaustive permit system. Then in the gas detector, the gas reading, what we do, we BLE Bluetooth reading, we go to the field, and the field, the location, hot permit location is geotagged, and from there through the BLE beacon it transmit the gas detector reading through sensors, Dagger sensors are there. Then it is updating the permit system, exact permit. Then for the OISD safety checklist of the tankers, this mobile app is developed. OISD, I think. So a lot of 46 checks are being conducted. Then robotic tank inspection, that is a common thing usually. E-logbook is a very exhaustively used in system in our refinery. All units and marketing terminals are covered under e-logbook. Then interlock, then this what we call this control valve, manual and auto status, interlock, auto, manual bypass, everything is configured. Plant maintenance is also SAP plant maintenance. We are not using Fiori, we are using a third party defined applications. Then all contract workers have been given access to the system and the tablets, and they go to the field and close this notification, updates the records, the measuring points and all. Then GPS is one of the solution. Around 50 vehicles are there which is running. The entire payment is done through GPS. It's like sort of Uberization, and also the fuel filling. We provide fuel to fuel. It is a smart fleet monitoring. So earlier bill processing used to take 5 months, 4 months for all this logbooks, manual recording. Now it is everything is digitized. So this is how all the tour, the distances travel and all these things comes, and the concerned team person authorize or approve it, and based on that data populated, it is integrated with SAP system, and the vendor, the vehicle operator submit his bill through a mobile app, and it's populated back in SAP. It is a combination of both GLONASS and the Galileo. So only GPS is not sufficient. We have discarded GPS. So this is also a very custom made and very quite behind the scene, lot of complexity is there. So yeah, this is how bill made, bill provided, and the SES LIV getting created. So entire process, in 5-6 days, entire billing cycle of all the vendors completed. Then it is one of the flagship initiative. It is with IIT Guwahati and CDEC Bangalore, then one of the startup and NRL. So entire procurement cycle in any industry, I would say in oil and gas or bid, procurement is a very cumbersome in the PSU context. So it is basically grounded in rules, grounded in governance, grounded in some circulars. How you can bring in AI and such sort of probabilistic modeling or other things, but we could do it in the first leg. So entire tender process from an NIT generation to the award note generation, it was automated. Now we are in the second stage, developing a small language model with the help of CDEC and the entire we are using their India AI infrastructure at the CDEC, their data center in Bangalore. So this, I'll briefly tell you. It is from where we are doing. Already we have covered NIT generation, notice investment generation, then BEAD evaluations. Then BEAD evaluations comprise of what? Compliance to the GFR rules, compliance to PQCs, compliance technical compliance, then the vendor, other things, then turnover, PAN, seal and signed or not, all these things. Then if it is successfully gone through the next stage, then award notice generated. And this is a solution always human in the loop, not entirely driven by AI. And it is a complex solution, not only GenAI or SLM, but NLP is there. There are some other APIs, then VLM is also there. So I will not go into technical details. So one of the impact, I would say that NIT drafting time from 2 days to 6 minutes. That was the impact. And recently we conducted one bid. We received around 250 plus documents. It was done in I think hardly an hour. So this is the whole thing. And second stage, we are building need assessment, purchase requisition, and the reporting. This is the thing what we are doing, anti-TPO access and tax. RAG is also used, then Langchain is also, I will not go into detail. This is the model architecture, how you are doing. It is hosted in Amazon, AWS, Cloud Infra. Then some of the key lessons what we have learned, I could have gone into detail, but now presently we are doing a 5G CNPN with 6 nodes covering the entire 750-acre refinery. So which is being implemented with the government of Assam and Amtron and the ministry, MAT, DP. Then GenAI knowledge base we are building. 3D printing we have started doing in collaboration with Amtron. Then soft sensors, other areas like sulfur prediction and some of the critical process parameter prediction. These are in the pipeline. Inventory forecasting. These are ML based and corrosion intelligence. This is also another initiative with R&D with a reputed party that is in the advanced stage. So I'll sum of everything. Our initiatives are already outcome driven and order beyond the production POC stage. It is in the production, and all are driven by tangible outcome, and there is support from the management and leadership. Push is there, and team selection and change management is very critical. It is the initiatives are driven by business and enabled by IT or the digital transformation. It's businessless and human-centric approach is extremely important. There's a human centricity which we in the heat of the moment or in the technical jugglery or we tend to forget. But people want simple thing in a very intuitive way. So that's all. Thank you.